All right, the homework tonight is a worksheet practicing average rate of change and linear regression. I don't think I had to use this all that often on this worksheet, but if we get a decimal that is longer than 3 places, we will always round final answers to the nearest thousandth, which is 3 places after the decimal. And I've said this before, but that is because that is the rounding required for the AP exam, for pre-calculus, and for calculus, both AB and BC. And on our pre-calc test, if you round differently when they tell you to give a decimal approximation, if you round to 2 places or 1 place or whatever, you will not get the point. So round to 3 places. Use the line graph shown below to answer parts A through E. Show all work that leads to your answer. Right? The graph shows the net profits, Y, in billions of dollars of Apple Incorporation for each year X from 2010 to 2017. 0 represents 2010. Find and interpret the average rate of change from 2013 to 2017. So that is from, let's see, 0 is 2010. So that's from X equals 3, yes, to X equals 7, because 0 is 2010. So these are years after 2010. All right, so the average rate of change, let's see, 3 to 7. Okay, so the average rate of change is 48.4 minus 37 over 7 minus 3. Remember, if you want to use your little alpha y equals fraction thing, that's kind of cool. So that was 48.4 minus 37 over 7 minus 3 is just 4. 2.85. I almost put approximation, but that's exactly what it was equal to. Interpret this. So remember, we always start with on average to show this is an estimate. On average, Apple's, what are these? Profits. Apple's net profits increased because it's positive by, these are dollar amounts, so dollar, 2.85 billion per year. Or you could say slash for per. $1 billion per year. Make sure you say the years from 2013 to 2017. Which interval contains the lowest average rate of change? So again, we're looking for the lowest number slope. So the first thing I'm looking at, I'm not going to calculate every single slope. First, I'm looking at negatives. Are there any negatives? So increase, increase. Here's a decrease, increase, increase. Here's a decrease. So our only candidates are between 2 and 3 and 5 and 6. And then the lowest number is which out of those two, which one is the lower negative number. So I can kind of see the steepness. I'm pretty sure it's 5 to 6. But again, it says show the work that leads to your answer. So always show some calculations here. So from 2 to 3, we've got 37 minus 41.7 over 3 minus 2. So 37 minus 41.7, negative 4.7, divided by 1. And then the other AROC is 45.7 minus 53.4 over 6 minus 5. Oh, 45.7 minus 53.4. So that's negative 7.7. So because we're talking negative numbers, which one is the lower number? The one that's further down the negative number line is lower. So it would be between, it's the second AROC. So that was between 5 and 6. So which interval contains the lowest average rate of change? I would say the lowest, I think you can abbreviate like this on your AP test. Lowest AROC is between, let's see, what are these years? 2015 and 2016. That's when Apple, translate that. It's when Apple lost the most money, right? Net profit was the most negative. Use the points on the graph to create a linear regression model for the net profit as a function of time. So it's not just pick 2 points and find a slope and point slope. This is use these data points to go into stat, edit, and plug these in. So remember, this is stat, edit. How do I get rid of these other numbers? So go up to the top heading, press clear, enter. Don't press delete. Here's what happens if you press delete. Delete deletes the list. Now you can get it back. If you delete the list, say you're like, oops, 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 oops. Don't go through and start renaming them. Just do stat, setup editor, and press enter. And then when you go back to stat, edit, they're back. Okay, so what are you supposed to do? You're supposed to go up here, press clear, enter, done. All right, so we're typing in the X values always into L1. So 0, 0 to 7. All right, and then type in the Y values. Make sure you get the right ones corresponding to the points. So it's 14, 25.9. At 2, we're at 41.7. And then we go to 37 and 39.5. At 5, you're at 53.4. At 6, you're at 45.7. Last point is 48.4. All right, so enter the data into your stat edit. And then we want to get a linear regression. So we're going to go stat, arrow over to calc. Let's choose option 8 just to be consistent. Linear regression. L1, L2. Make sure you store the equation. Just always get in that habit whether you're going to need it or not. So go down to that line, and then it's alpha trace, Y1. Calculate. Now, write this down without rounding it. So for this problem, we want the net profit as a function of time. Do they give us variables instead of X and Y? So it says X equals 0 for the input. Oh, no, it does say X and Y. Okay, so we don't have to change our variables. So this is Y equals 22.475 plus 4.492857,143 times X. All right. Use the linear regression model to predict the net profit in 2020 and 2024. So how many years after 2010 is 2020? 10. What about 2024? That's 14. Which prediction is likely to be more accurate? Let's answer that first before we do these. It's the same thing that we did in our notes. Which one is more accurate? The answer will always be whatever point is either within the domain that you're given or closest to the domain that you're given. So I'm going to change how I worded this from the notes. So because the linear model was created from 2010 to 2017 data, the 2020 prediction is closer to the domain and likely more accurate. Okay, and then we need to find both predictions. So y of 10 and y of 14. Use approximately equal to here, since we're going to be rounding. Remember, we saved this in y1, so you don't have to type all of this. You just go to alpha trace, y1 of 10, round this to 3 places. So $, what was it? 67.404. What's the label on this? It says net profit in billions of dollars. Always label your answer. And then what about 14? So now you can do alpha trace again, or on most of the newer calculators, you can go up here and grab this line and press enter and just change the arrow over and just overwrite that 0 to be a 4, 85.375. Even though I didn't round that, I still have approximation because remember, this model is not perfect. These are just estimates based on the model. So that's how many billions we call the net profit based on the model. Okay, the residual plot is shown below for the linear regression model. Based on the residual plot, is the linear model an accurate model for Apple's net profit between 2010 and 2017? And then based on the list of residuals, does the linear regression model overestimate or underestimate the net profit in 2012? So these are both common questions for our AP exam, whether we're looking in multiple choice or free response. So let's take a look at this. The residual plot kind of has a pattern again. It's not a perfect parabola, but it's weird to have this kind of M shape looking thing. So if I'm basing this on the residual plot, is the linear model an accurate model? It's kind of hard to tell with so few data points, but I would say the linear model may not be a good fit because there is somewhat of a pattern. In the residual plot. I don't have to say what I think would be better. Like when we saw almost a clear parabola in our notes, we said, oh, maybe quadratic's better. Maybe this is some sort of like, I don't know, degree 4 or something, or it's probably just that there was fluctuation in the graph. Remember, all this does is if we want to see the graph, we could zoom 9. All this does is show that, like, yeah, that sometimes the points are above, then they dip below, and above, and then back below. So I don't know what model's better, but this one might not be great. Also, what about the residuals? Let's take a look at the residuals themselves. A residual of 8, 10, when your Y values are just at the maximum or in the 50s, like 10 is 1/5 of 50, that's pretty big. And 14, 8 is more than half of 14, so those are large residuals. So the linear model may not be a good fit because there's somewhat of a pattern in the residual plot. I might throw in, and the residuals are fairly large. All right, now what was this other question? Based on the list of residuals, does the linear regression model overestimate or underestimate the net profit in 2012? So first of all, what X value is 2012? 0 is 2010, so 2 is 2012. So we're looking at this thing. That residual is 10.239. So I'm going to say that. In 2012, the residual is 10.239. This positive residual means that the point that we're looking at is sitting above. It's this point right here, right? Here's 0, here's 1, is sitting above the line of best fit. Remember, this is the line of best fit, just sort of flipped on its side. So a positive residual indicates the model. Is the model over or under this point? It's under. So the model underestimates the actual net profit. I know the wording on that is weird. A positive residual means an underestimate. It's because we're talking about the model. So I just think of it as like, just pay attention to what it's asking. Is the model over the point or under the point? That's really what that's asking. The model is under the point. This is an underestimate. All right, let's take a look at this problem. So the table below shows the sales S in billions of dollars for Nike Incorporated for each year from 2011 to 2017. T equals 1 represents 2011. So nothing with my calculator quite yet. It says find the average rate of change as a decimal approximation from 2011 to 2017. So from the first point to the last point in billions of dollars per year. Show the work that leads to your answer. This problem, by the way, is modeled after FRQ number 2. FRQ means free response question. They're kind of set up like this. So I'm trying to expose you guys to this language and format early on. Okay, so find the average rate of change. You have to show work. So AROC is equal to 34.4. Now, actually, because we have function notation, this is a good habit to get into for calc too. Let's make this S of 7 minus S of 1 over 7 minus 1. And then I'll show that that's 34.4 minus 20.9 over 6. And then I'll show what that comes out to. So 34.4 minus 20.9, divide that by 6, 2.25. Find that average rate of change, show the work. This is in billions of dollars per year. Now, on the AP exam, they're giving you credit for your number answer, but I think it's a good habit to label. If they tell you what the label is, they're not necessarily requiring you to write it down, but for calculus you do. So you might as well get used to it now. Use S of 7 and the average rate of change calculated in Part A to approximate the sales for Nike Incorporated in 2024. So what X value is 2024, first off? 1 was 2011, so we're back to years after 2010, right? So 2024 is 14 years after 2010. Okay? And so what they're asking us to do is just come up with a point slope equation, right? So we've got the point, what do we have the point? 7, 34.4. And we're trying to use a slope of 2.25. Now, if this were rounded, we would use the unrounded version, but that was terminating, so that's fine. So use this point and this slope to approximate a value for S of 14. All right, so let's just give an S of x equation to begin with. S of x is approximated by, let's do this. S of x minus point slope, 34.4, is approximately equal to our slope times x minus 7. All right, so what are we trying to find? Oh, sorry about that. What are we trying to find? We're trying to find S of 14, okay? So plug in 14 for the x right here. Now do the math. S of 14 is about equal to 2.25 times 7 plus 34.4. Again, this is literally always the second part of our number 2 free response question. Use a point and your slope to predict a value. So let's see what this comes out to. 2.25 times 7 plus 34.4, 50.15. Okay, so S of 14 is approximately equal to, keep forgetting what it is, 50.15. Now, what's the label on that? Billions of dollars. It's not per year. This is not a rate. This is an amount in 2024. That's their net profit. According to this is like a little secant line that goes through the model. Use linear regression to calculate a model for Nike sales in billions of dollars as a function of time and years since 2010. So go back to this table, press Stat, Edit, clear out the old, enter in the new. So we're numbering 1 to 7 into L1, and then into L2. Make sure you carefully type in these values. All right, so then we're going to Stat, Calc, Linear Regression. Every time you store in Y1, it overwrites whatever was in there before, so you don't have to worry about going back and clearing it out. All right, so I am getting, I'm going to write this down unrounded. So let's see, it's not y equals, it's s of x, because x was time. So s of x is equal to, don't round this, 19.01428.571. That's A. And then it says plus bx. So plus 2.228571429 times x. Use a linear regression to create a model for Nike sales as a function of time in years since 2010. So that's our model. And then the next part says use that linear regression model to approximate the sales for Nike in 2024. So again, that's when X it's years since 2010. So that's 14. So S of 14 is approximately equal to, let's see, alpha trace y1 of 14. We can round this to 3 places. We used our unrounded equation to get the most accurate value we can, so 50.214. And I'm going to label it billion. This is is it sales or net profit? I feel like I kind of switched. Oh no, it's sales. Okay, I think I was just saying net profit from a previous problem. And yeah, we should find that our answers are reasonably close, right? This average rate of change I got here is pretty close to what the model says the slope ought to be. And my prediction using the average rate of change is pretty close to what the linear model got as well. So they're not going to be completely wildly different. The list of residuals is given below in L3. Which point is farthest from the linear regression model? Does the linear regression model overestimate or underestimate the amount of sales? Explain using the residuals. So let's answer the first question. Which point is farthest? So this is really the farthest will be the greatest absolute value of the residual. Because if we're talking distance, if I'm 100 feet behind you and someone else is 1 foot in front of you, even though I'm behind you and I might say I have a negative residual, my distance is the largest. So let's take a look at just overall. Negative 0.3, negative 0.6 so far is my winner, or positive 0.6 is my winner. So yeah, it is a positive residual anyway, so I didn't need the absolute value. But if that were negative, that would still be the greatest distance. So that was when x equals 2. So the point, which point it says? So the point 2 and then 24.1 has the largest residual. So it's farthest from the model. And remember, you can zoom 9 to check this out. What is that? The second one. Hard to tell because they're all pretty close. But yeah, seems to be the farthest from the model compared to the others. There's another question. Does the linear regression model overestimate or underestimate the amount of sales? I meant to say at this point. Okay, so this is in 2012. Okay, so again, at the point 2, 24, 21, is the line above or below? So if the residual is positive, let's say, in 2012, the residual is greater than 0. Okay, what does that mean? You might want to sketch this out for yourself. It means that the point is sitting above the line. But the question is saying, is the line over the point? Or is the line under the point? The line is under the point in 2012 because of this positive residual. So in 2012, the residual is greater than 0. So the linear model underestimates the sales. All right, so that was our final question for this problem. So I know this takes a lot of adjustment, not only with the writing, but also with the calculator stuff. So if you need more practice or if you have questions about the calculator or anything else, please make sure you're coming into office hours or flex.